Okay, guys, welcome back to ITD with Mr. B. Today we're going to do a sub-assembly of these two sheave components. So we've got the sheave pulley, that's sheave A, and the bush that goes within it, that's sheave B. So, assemblies. Up in new, through our metric library, we've already drawn the parts. Now we're assembling them, and we're using the standard millimeter IAM. So double click on that one, should open up quite quickly. Now to place your components in, you want to go up to this one here on the left hand side. Mine says place at the moment. Yours might say content center. Best way to think of your content center is a hardware store. It's got all sorts of stuff. It's the Bunnings of Inventor. So in place, I find my two parts. I want to put in the sheave 7A first. So there it is. I just want one. Hit escape. I'm just going to rotate this around a little bit to the exact rotation I want. I want it to come back to this as my home. So I can right mouse click on that corner, set the current view as home, and we'll just go fit to view. So if I add more stuff to it, it will automatically adjust the size of the view to whatever's on the screen. Okay. While I'm here, I'm also going to right mouse click on its name, and I'm going to click here, grounded, so that just pins it in position, kind of like the pin icon here. Through that part says, hey, this is locked in position, it's nailed down, it's not going to move. All right, place. Placing in the bush component gives you a nice little preview of what we're about to open and place in here. Just want one of them. Escape to get rid of it. In the constraints, we've got two round cylindrical type things. We might as well use the insert constraint. We probably used it last time when we were doing the sub-assembly for the thrust bearing. These two parts, I want the outside edges of them to be aligned. Hit that one. And then it's just a matter of choosing which corners of a face are going to align with one another. Bit of a no-brainer, that one. Okay, so, okay, I don't have another one to do. If I zoom in here, I can grab, remember our little grease groove? Look, if I grab this part, I can spin it inside the sheave. The sheave's locked in place, it's not turning. The sheave B, the bush, is turning. Now, I want to align them so that it actually locks that grease groove at the top, very top of the sheave pulley, 7A. To do that, I need to expand both of these. Yep. I need to look at their origin planes. So these are the planes that were around when we drew them. I'm going to look at this XY plane on both of them. I'm going to make it visible. So you do that by, I'll show you on this one again. Click on the origin folder, go to that particular plane that you want. Oh, I don't want that one. I want that one. I want that one. My YZ plane on this one. Right mouse click on it, and then go to visibility, select that, and you can see the plane. There it is. Okay, constrain. In constrain, I think I want to mate them. I think in this standard one here, I think I wanted to go face to face. Let's try that. I want to take that plane and align it with that plane. Hey, presto, they're now aligned. If I click OK, that goes away. They're locked in. I'm probably going to turn the visibility of these off again. It's as easy as right mouse clicking on it, turn off the visibility. It's one of the most direct ways of doing it. Now, if I try and grab that inside one, it tells me, hey, you can't move that. It's aligned with this one out here. It's locked in place. All right, so that's part A. Now then, to drill the hole in here, I'm going to want to do a sketch. So I'm going to do my 3D model, start a 2D sketch, and I need to put it on a work plane. I need to put a center crosshair here for me to drill a hole on. But I need a work plane to put it onto. So I need to find a work plane. I can put it so that it is a tangent because it's circular. I really don't have an edge to work on, but I can do it parallel to a plane. So let's go with this one here. I want it to go on this curve, but I want it to be parallel to my, no, that one, XZ plane. Now I've got a work plane I can work with. Let's put a sketch on that. Can I? Sure I can. There we go. Even gives me a little bit of a heads up on where everything is. I'm going to put in a point. I'm just going to put it there for starters. They're light green. They're kind of hard to see. If you zoom in, it's there. How do I want it to align on this thing? I need to project in some geometry. Look, let's take that outside edge. That's it. That's all I want to use. Whoopsie daisies. It's just a bolt falling over. There it is. I want to take that and I'm going to place it a bit closer to where I want it to go. I can probably see it a bit better here. There's a bit more contrast. Okay, let's use my vertical constraint. And it's going to go horizontally as it was. Wood. Okay, it needs to line up with the center of that line. Yep. Dimension from the line to the crosshairs. Now this needs to sit in 20 millimeters. 20 mil. Yep. Finish the sketch. This new work plane. I'm just going to hide it. I don't really want to see it. All right, this is just a sketch at the moment. In my, where are we? 3D model. I want to draw a hole. The hole command is really cool. It's just popped up on my other screen here. There we go. It's already identified that there's a point put in place and that I probably want to put a hole on that point. So it's selected one. There's a few different ways you can choose that. If you use a drop down for placement, you'll find a few different ways. Now this hole is just a simple hole. However, it has a counterbore in the top of it. Termination, how far is it going to go? This one's giving us a distance. This one's going to say through everything and never stop. And this one says, oh, stop at this next face. So it's asked me to select a surface. I want it to stop on this surface. Okay, it won't go any further. Okay, we'll go recognize that, hey, look, there's a surface down the bottom here, and it's going to go to that. Now then, the sizes of the hole. What are we drilling? We're drilling with a drill. That's fine. How big is the diameter of the top of this thing? Well, looking at my little plan here as I turn it over. It's going to take an M12 thread. Let's make that hole 10.5. Whoa. 10.5. The reason I say 10.5 is we're going to use a 12 by 1.5 millimeter thread, metric thread. And a good rule of thumb, if you're drilling a hole for a metric thread, if you use that 1.5, which is measuring the pitch, and take that away from the original diameter, it's pretty close to the correct tapping size for your hole. Okay, so in this case, 12 take away the 1.5 because that's the pitch, gives us 10.5. So let's go with that for the diameter. Depth of the counterbore is 10 millimeters. 10 deep. Oh, I did that thing again, didn't I? 10 with an extra M for, caps locks on, millimeters. And then the remainder of the hole, if we select this one down here, is going to be 5 millimeters in diameter. 5. Okay. Lucky last thing I'm going to do is I'm going to put a thread in the end there. If I can find where the thread has gone. Not so easy. Well, we won't worry about the thread right at the moment. The basics of the hole is there. I can put into my detailed drawings and denote that that will be a 12 by 1.5 millimeter thread in the future. Okay, so that's all done. Good idea to name it here. What are we naming it? This is part 7, and it is the sheave. No A or B. It is A and B, all done, ready to go for that final assembly. Okay, next video we're going to do is we're going to start looking at how to do the hook itself. So that's going to be a lot of fun with a foundation sketch, a few profiles to move a loft through with rails. So if you want to have a look at that one and have a think about it, have a crack, see what you can do. But first, get this one done. Have fun. See you later.